image pop up during the webinar. Thank you for your cooperation. So before I start, let's do a quick review of our past webinars. Okay. So on 20th of May, our very first webinar, we have invited speakers from Universal Robots, a company that is famous for its collaborative robots, followed by 3D Picket, okay, 3D vision cameras that is able to detect objects that are overlying any orientation, which is mainly for beam picking and palletizing applications. And lastly, Easy Robotics, a company that produces standard systems that are easy to move around, mainly for machine handling applications. Okay. And on 27th of May, we have invited speakers from real-time robotics, the powerful applications that avoid collisions between robots and humans, followed by On Robots, an intelligent robot gripper provider. And on 3rd of June, we have invited speakers from Robot Master to talk about CAD/CAM software for robots, followed by Zimmer, specialized in mechanical parts and grippers, and lastly, introduction of 3D Picket camera by IIOT. So these are the programs that have happened during our past webinar. So for those who miss it, not to worry, just subscribe to our TDS YouTube channel and we will upload all our past recorded webinars into the YouTube channel where you can view our past webinars and keep yourself updates to our latest technologies that we are able to provide. So just remember to click on subscribe on our YouTube channel. There's a QR code on the top right hand corner. You can just simply scan it and it will bring you to our TDS YouTube channel page. Okay. So lastly, before we begin, I'd like to introduce our next week TDS webinar, okay, on the 17th, same time, same day, every Wednesday, 3 p.m. We are going back to talk about robotics topics. This time we are talking about polishings. Okay, we have invited speakers from Pushcops, okay, specialized in compliant tools that are used for robots, and we also invite speakers from ABB to talk about their industry robots and maybe share some of their applications. And lastly, Unibots, okay, who are specialized in ABB robots and got famous for their UV cleaning virus robots with temperature reading function. It's 2-in-1 function robot. It's a very interesting topic that is so relevant to our current situation. So definitely a not to miss robotics webinar, okay, that you must attend to gain the first inside info of the latest technology that is happening around the world. So remember to sign up when the registration link is available. Okay, that's all for me. So let's invite our first speaker of the day, GK from ISDN Software, to talk about robotics IIoT, powerful SCADA that can display real-time data and simulation of robots in production process. Hi GK, are you ready?
Yeah, I'm ready.
Okay, pass the mic to you. Okay.
Okay, good afternoon. Hope you can see my screen, my presentation. Max, can you see it?
For me, no, I don't see. Okay, yes, now I can see. Yes, great.
Okay, great.
Yes.
Good, thanks. Okay, good afternoon, everybody.
Okay.
I'm GK. I'm from ISDN Software Business Unit. So ISDN Software basically is focusing on providing the industry automation solutions as well as Industry 4.0 solutions. So we cover solutions from the process integrations, device connectivities to some production management solutions, and all the way to the advanced applications like predictive maintenance, the machine learning, artificial intelligence, and as well as the digital twin solutions. So today, what I'm basically want to go through with you is solutions that we offer for integration the logics and the motion process, all right, for visualizations. So this is how the solutions architectures looks like. All right, so the solutions allows integrations to all the motion controllers, like the Monicom motion controllers, the drive and servo motors, and we also have the integration with Universal Robot, Yaskawa Robot, and we can also integrate with drives and servo motors. All right. So the solution itself, which is showing inside this dotted boundary, consists of two different layers. The first layer is the what we call the unified control layers. And this layer is basically to do all the control logics, all right? And the control logics is the merge of the control programs for logics as well as the motion control. So meaning that you can use one IEC 61131 development environments to develop both the control logics for both the logics and the motion control. So from there, the data, right, that generated from all this connectivity with the robot, with the controllers, all these data will be passed to the second layer, which is the visualization and analytics layer. So at this layer, basically we can create the visualizations, and we can also use the data that coming from the control layers for some other applications. So the logics layer, the control logics layer, is what we call the connected asset layer, which means to provide the connectivity to the asset. The visualizations layer and the analytics layer is what we call the connected application layer. So this is a layer where all the applications, such as the visualization, data analysis, or even the predictive analysis, augmented reality, this is where this application will be running. So this is the solutions that we are offering. So the solutions, the demo that you're going to see is basically utilizes what you have seen before. Okay, basically it utilizes the block diagram which you have seen before and applied it for robotic integrations. So by doing that, we are offering a immersive simulations and visualization user experience, okay, using a 2D and the 3D type of visualization. So the solution itself provide 2D and 3D process digital model. And this digital model is created, all right, from any of the CAD file, all right, and we will be converting this CAD file to a 3D model and link some of the graphical elements in the 3D models using the real-time process data acquired from the process controller. So by linking all these 3D model with the real-time process data, so we will be able to generate some interactive monitoring and control applications using software like Wonderware InTouch or Wonderware System Platform. Okay, so far we have been using these solutions to provide the simulations, provide the connectivity with UR Robot, Dobot, Yaskawa, or even Schneider Robot. Okay, so and we can use these solutions to simulate some robotic motion and control. Okay, instead of using the real robot. So this allowed what we call virtual commissioning, all right, to be done, meaning that you can commission your control program, you can commission your process even before the physical process is built, even before any physical robotic is being installed. Okay, so and you can also use these solutions for doing some process simulations, all right, so that from there you can have a digital twins solutions. So these whole solutions in itself support cloud integration as well. In the demo, you will see later on. All right. So from the platform, all right, from the connectivity with the process control layers, we are able to send some of this information, some of this data into the cloud. And that is to use some protocol like MQTT or REST integrations through a data format, JSON data format. All right. So all this capability, all right, we are actually providing it in our platform. And from the platform itself, it can be expanded, all right, to work with or to integrate with other production management solutions, such as MES, asset management, AR, or VR. So this is a rough overview of what this solution is all about. So what are the benefits? So the benefit from this solution is, number one, okay, it really maximizes the engineering efficiencies. As I mentioned before, the solution allowed the process and motion control to be programmed in the same environment. So when you're doing your process logic control, all right, you can also utilize the same control editor to do the motion control. All right, our solutions offer the libraries for the users to do both process and the motion control, and using the already familiar 61131 programming environment. And we will be offering some functional template, okay, as part of all this inside the control editors. We'll be providing some predefined functional template, and this template allowed robotic control, efficiency calculation, historian integration, or SCADA integrations to be done using the template. And on the SCADA side, we will also offer some of the predefined SCADA graphics. All right, so using this predefined SCADA graphics, you can basically just drag and drop some of this graphics template into the HMI to create the final HMI integrations, right, to monitor the whole integrations. So obviously this HMI graphics template, predefined HMI graphics integration template, will also consist of a 3D robotic model, which you'll see later. All right, so we are not just only offer a 2D graphics template. We will be also offering a 3D robotic template, which you can embed inside the HMI. And this HMI that we are talking about here, we are using the Wonderware InTouch HMI or Wonderware System Platform HMI. So the whole solution architectures are basically based on the off-the-shelf software. All right, and this off-the-shelf software consists of ABB Wonderware software, InTouch or System Platform. And as for the 3D robotic model, we are utilizing Unity 3D runtime environment. So we will be providing a 3D robotic model, all right, and we will compile it in the runtime environment. So this runtime environment can be embedded inside Wonderware HMI software. So to make the 3D rendering as part of the overall HMI to provide this immersive type of user experience to the end user. And the whole solutions is created and will be supported, and all the hardware and software can be purchased and supported by ISDN software. All right, so this is the benefit. And this is how the solution component looks like. So we have a robotic. All right, so this can be UR robot, Yaskawa robot, Dobot, or any other robot. All right, so using the standard integrations in the and we offer all these drivers as part of the functional template in the control editors. So all this integration will be embedded inside the standard control editors. And from the control layers, we'll be communicating Modbus, OPC, UA, TCP/IP, whichever protocol, into Wonderware system platform. So from here, the HMI will be created, all right? And this HMI basically will consist of some of the predefined graphical template, like what you see here, as well as a 3D simulations templates here. And you can use all these graphical templates to create out the HMI screen. So this is a 2D and 3D visualizations. This is the SCADA integrations. This is the control, and this is the physical process itself. So in the demo, all right, basically this demo consists of multiple screens, but because we are doing this through a web meeting, so I basically do it using a video to capture the demo. So you will see that after this slide. So the whole visualizations, you can have, you know, a 3D visualizations, you can have a 2D data or 2D integrations to look at some of the motions, some of the logics, and from the data which you capture from the process, you can also run some simulation software. Like here, what you see here is a simulation on the warehouse to study all the AGV motions for the warehouse. So from here, you can basically evaluate, all right, the performance of all these AGV, all right, and also what are the bottleneck, okay, on number of AGVs to serve some of the inventory or material movement. So this could be some of the dashboard, okay, looking at the whole production plan all over the different geographical area, and you can create the dashboards to compare some of the production performance. All right. So this is the overall HMI screens, okay, to help you to monitor from a process. Okay, so first it will give you a 3D, it will give you a 2D process overview, and it will give you a simulation environment, and it will give you a dashboard. Last but not least, any of this information can be published into a mobile device. All right, so that is how the overall setup for these solutions. Right, so now let's move on to the demo itself, the demo video. So this is a robot. All right, so from here, the robot is controlled by a control editors, which is running in the codices. So this is a codices control environment. This is a 2D visualization. So from the control environment, okay, so maybe I can move back here. So from the control environment, so basically a 2D graphics can be created to look at the function of the robot, the status, the different status of the robot, and it can pull the informations like the cycle count from the robot. All right, you can start and stop the production run or start and stop the robot. You can even do a simulation. Okay, you can download the control programs, but you can run it in the simulation environment to see how the simulation runs before you deploy the program into the actual productions. You can analyze, all right, each different cycle time, all right, and each different loading, all right, that the robot is going through. And from there, you can basically do a forecast on the performance by the robot. And from this forecast, you can see whether you can meet your shift or whether you can meet your production target. So this is in the 2D environment, okay, to monitor onto the robot. So all these informations are basically created, all right, and acquired from the control process, which you have seen in the codices, all right, that's running in the codices and linked up with the actual robot. So the data that is created, from, the 2D, all right, environment, all right, and from the robot can also be sent to the cloud. So this is a cloud environment where all the previous runtime, the production target. So this is in the cloud, okay? And this software is called ABB Insight. It's a hosted services, sit in the Azure cloud environment. So all this data that coming from the robot can be sent into the cloud, all right? And you can basically look at some of the raw data in a trend, like what you see here. And these are the different states of the robot, running state, stop state, and so on and so forth. And these are some of the performance, okay, like how many units, what is the performance of number of units per hour. This is the average cycle time and how many units has already been processed by the robot. Okay, so this information will be published to the cloud, and the users can basically access to this information from his mobile phone. So this is how the whole setup looks like. So a robot, a control environment, a 2D monitoring, and a cloud integration. So as I mentioned, not just only that we can do a 2D visualizations, we can also have a 3D visualization. So this is a 3D visualization of the same robot as well as another UR robot. So this is a 3D simulations of what monitoring from the robot itself. All right, so other than giving you a 2D environment, you will also have this 3D monitoring. Okay, and besides than that, we can also have, I'm going to run a 2D simulations to show it to you. On my PC over here. So for our 3D simulation model, this 3D simulation model can be linked with the actual process using OPC UA, all right, can be linked with the actual PLC using the OPC UA. So this is our 3D simulation model, a digital twin models. Now this is linking up with a OPC UA, all right, with a control logic which I'm running at the back end. All right, so this control logics is to control this process. So I do not have a physical conveyor belt. So that's why I'm using a digital twins, create up a 3D simulation model, link up with the control programs using OPC UA, and using that control programs to run the process that you see over here, to run the simulation that you see over here. So this is basically a simulation process that linking up with the actual control process. Okay, so you can see there is a gantry robot, okay, 2D gantry robot, and there's a sensor. This is a sensor. So when the can, there is a conveyor. So when the can is removed, all right, the conveyor will start. And when the can reach the sensor, it will command the PLC to stop the conveyor. And it will command the gantry to pick up the can and place it into the box. All these logics is done in the control layer. And from that control layers, basically, you can have a visualization, like a 3D visualization, to look at those control logics. And these are all created using the ISDN solutions, like what I mentioned to you just now. All right. And this can be, obviously, you can create another 2D UI to turn on, turn off, some of the conveyor, rather than, control it by the PLC, control logics itself. Okay. So that basically, all right, that basically demonstrate what our solution is all about. So using our robotic control solutions, all right, we are able to integrate a plant floor. Okay, we are able to empower a smart factory. Okay, with that ISDN solutions. So we are able to integrate all the different components, all the different devices, all right, from the the PLC, from the environmental control, from a robotic AGV, all into a common platform. All right, and from there, offering you a 2D and 3D visualizations. So in summary, okay, ISDN solution provides, all right, as I mentioned, a industry automation system, industry automation solution, and the industry 4.0 solutions to the customer. Okay, so our offering is a holistic approach towards a full digitization transformation solutions. So it empower our customer with a timely information for making informed decision. Okay, by providing all this data in a 2D or the 3D visualization, and by providing the correlations of all this data with a contextual information around the event and the asset. So our solutions can be further enhanced to incorporate some of the innovation features such as the AI or predictive maintenance. All right. So maybe in future, all right, I can demonstrate some of these innovation features, how to enhance on the control platform which I've just seen, okay, to have AI and predictive maintenance. All right. So with that, thank you very much for your attention, and back to you, Max.
Hi, GK. Hi, GKA. Thank you for your wonderful presentations. So I was supposed to inform you to turn on your camera during presentations so that our audience will know who are you, okay? But it's okay. Maybe we can do it during Q&A sessions, okay? So next, we will have Martin from HMS, a company that produces IoT products that helps to connect machines and automation machines into the cloud, enable you to do data logging, SMS, or even email alerts and so on. Hi, Martin, are you ready?
Hello, Max. Yes, I'm ready. Thank you for your introduction. So I will share my PowerPoint.
Oh.
Can you see my screen?
Oh, yes. Perfect.
Okay, great. So hello, everybody. Thank you very much for attending this webinar. And thank you to our friends from TDS for inviting us. I'm Martin from HMS Networks, a Swedish company. And today I will introduce our E1 brand. So here is the summary of my presentation. I will start by introducing the situation, how we see the situation with IoT at E1 and HMS, and the challenges it faces. Then I will introduce our company and the three value propositions that our E1 brand is providing customers. And at the end, I will introduce our product line more specifically. So IIoT, everybody is talking about it, as you have all heard, I guess. And according to a survey from Microsoft that was done last year, nearly 9 out of 10 companies think that IoT will be critical to the success of their business in the future. So everybody is interested in IoT, and a lot of companies are already trying to adopt these technologies. However, IIoT is not easy to implement. There are many challenges. So of course, there are concerns about security, cybersecurity. And according to the same Microsoft survey, 97% of the companies are worried about this. Another big challenge is the cost. IIoT is not cheap, and especially when you need to scale up to your production, it costs a lot of money. And even though you have to invest a lot of money, the return on investment is not always clear. So people hesitate to invest that much money. And of course, there is the technical complexity. IoT requires new knowledge, and a lot of companies don't have the resources and skills to apply these technologies like cybersecurity, cloud technologies, etc. So many challenges and a lot of companies simply fail. So about 30% of the companies fail their IoT projects at the proof of concept phase. And even the companies who can move to the next phase, the pilot phase, about 80% of them are stuck for 1 or 2 years without a lot of progress. So it's not an easy thing to implement IoT. And at HMS, with our E1 brand, we try to help our customers have a very smooth start with a very, very easy to use solution that can give very nice results in a short time. So HMS is a company from Sweden, but we have offices in 16 countries. So the closest one to you is probably our office in Singapore. And HMS is providing different brands. All of these brands are leaders in their fields, but today we will concentrate on the E1 brand, which provides remote solutions. So the vision of E1, the goal of E1 is to connect industrial machines across the internet. Our E1 products are all developed in Europe, in Belgium, and we are not new in this business. We have been connecting machines, industrial machines, to the internet since 2001, when we released the first industrial internet gateway. We also released in 2006 the first industrial cloud connectivity service called Talk2M. So we have many years of experience doing IoT, even before it was called IIoT. So inside an IIoT solution, E1 contributes to connect industrial hardware, usually industrial machines, automation equipment, to IoT software. So we provide communication gateways and a connectivity cloud so that all the connectivity can be done very safely and easily. We do this by providing 3 different value propositions to our customers. The first one is called on-demand remote access. So in this case, it means that you can do the maintenance of your machines through the internet. So you don't need to travel on site, for example, to reprogram a PLC or monitor a HMI. Our second value proposition is called on-premises data monitoring. So with this solution, you will collect data from PLC or sensors using our gateway that is installed inside a machine. However, this data will stay on premises. It will not travel through the internet, but can still be used for monitoring. And the final value proposition is what most people think about when we talk about IoT. It's simply to collect data from the remote site and send it through the internet to an IoT application. So it can be a cloud platform or a software treating this data. With these 3 value propositions, we provide a very pragmatic way for our customers to build their IoT application, because they don't need to start with the most difficult and expensive part of collecting data through the internet. They can start very easily in a few minutes with remote access, and remote access has a very nice return on investment because you avoid travels, so you save a lot of money and a lot of time very rapidly. I will now explain these 3 value propositions more in detail. So first one, on-demand remote access. To use it, you need to use 2 components. So one thing you need is our hardware, our E1 gateway. So we have 2 different families of E1 gateway, but you need either one. Both can do remote access. So our gateway that will be connected to our Talk2M connectivity service, a cloud service that can be used for free. So the only expense you have is one gateway, which costs a few $100s, and that's all. With only this small investment, you can start IIoT. So the gateway will be installed inside your machine, usually inside a control panel, where it connects to PLC or HMI, all the devices that you want to remotely access. And our gateway, the E1 gateway, is also connected to the Talk2M service. Once you have done this, you can connect from anywhere in the world to your machine. So you could have, for example, a machine builder in Singapore doing through the internet the maintenance of his machine that is installed in the US. So you don't need to travel, you don't need to spend thousands of dollars with plane tickets and lose several days to travel to your customer site. Both the E1 gateway and the computer of the service engineer who will use our solution connect to our Talk2M servers. So these are outbound connections going from your secure network to the outside. There are no inbound connections. So in most cases, there are no need to change anything to the IT settings. The security of your office network or factory network is untouched. To use our solution, the service engineer on any computer connected to the internet simply needs to download our free software, eCatcher. It's the Talk2M connection software, connection client. You use this software to establish a secure VPN connection to your E1 gateway. This is done in only 2 clicks, very easy. And once this connection is ready, you can work on your automation devices in your machine as if you were on site. So you will use the software that you use to do the maintenance, for example, the PLC programming software, to get online with the PLC or the HMI proprietary software. So virtually, it's as if your computer was connected directly to your automation equipment with one very long, thousands kilometer long Ethernet cable. And we also provide some clients to connect from any mobile device. So not only from a computer, but any smartphone or tablet. What our customers do with our solution is mainly to reprogram PLC. When you have a trouble in the machine, you can download the PLC program, re-upload it, monitor it, etc. Also, a lot of customers use it to monitor their HMI, for example, from a smartphone, or connect to a camera to see what's going on at the site. So like on this image, it's really as if your hand was reaching from your office to a factory that is thousands of kilometers away. And we are compatible with any brands of PLC or HMI. So this remote access solution has huge benefits, both for machine builders or system integrators and their customers, the end users, because you can avoid a lot of service trips, you save a lot of time and money. And also you can provide a better response, a better support to your customers, so reduce the impact of emergencies, and the machines, the automation equipment, will have a better uptime. Here is an example of one of our customers. It's a very big packaging machine builder in the US, and since they use our solution, they could reduce the time needed to troubleshoot one of their machines from an average of 2 days to now 2.5 hours. So the machine is not down for 2 days anymore. The downtime has been reduced to only a few hours, and the customers of these machine builders are super happy because they save hundreds of thousands of dollars. And this machine builder himself saves a lot of money because he can avoid costly trips. This was our remote access solution, and it's our solution that sells the most. It's our best-selling solution. But we also have other solutions that use data collected on the site. So first one is on-premises data monitoring. So how does it work? Well, this time the gateway, our E1 gateway that is installed inside the machine, can read data from various brands of PLC or sensors using different protocols. So Mitsubishi PLC, Siemens PLC, Rockwell PLC, we support a lot of different brands. So our gateway collects data and it stores the data inside its internal memory. So it does historical logging. The data that is collected from PLC and sensors can also be used to send alarm notifications by email or SMS. So if you have a problem on your machine, you can be immediately notified. Our gateway is also equipped with a web server on which you can host a kind of virtual HMI, a dashboard. We provide a free software that allows you to easily create a dashboard that you can host on our gateway. So then you can access to this dashboard from your HMI, from your tablet or smartphone. You can access to this dashboard locally, but also remotely through our Talk2M remote access service. So in this case, you can monitor your application remotely from anywhere in the world, but the data itself stays locally inside our gateway. Since the data is not sent through the internet, usually customers accept this solution very easily because there's less security concerns since the data stays local. And we even provide some live KPIs. So we have a web portal called M2Web, and when a user connects to his Talk2M account through this portal, he can monitor his whole fleet of machines, all his machines in the whole world. He can see up to 6 KPIs for each of our gateway. So you could have, for example, this machine in Belgium, in Europe, this one in Spain, this one in Singapore. You can see in one screen the KPIs of all your machines. And we even have color codes. So if you have an alarm somewhere, you will see because the KPI color is orange or red. And it means you have an alarm inside this machine, and you can then do remote access to this machine to check what's going on. This service is completely free and is extremely easy to set up. It takes only a few minutes to do the complete setup. So for a first IIoT application, it's perfect. It costs nearly nothing, and it's set up in a few minutes. Of course, customers who want to do more will probably need to use, a dedicated IoT software. But to start, this is perfect because it's very easy. Here is a demo video. So I connect using my web browser. I connect to my account, and I see the list of my machine on this account. So some of these machines are in Japan, others in China, others in Europe. So I can monitor my whole fleet of machine also through a world map. And I can see that some of my KPIs are colored. It means I have an alarm on this machine. And then I can connect to the local dashboard. So this time, now I'm connected directly to the gateway that is inside my machine in Belgium. And I can check the alarm history or the dashboard to see more detailed value of the machine and do a precise diagnostic. So all of this can be used for free. You only need to purchase one of our gateways to use all this, and the complete setup takes like 10 minutes if you're already comfortable with our solution. And even if it's your first time, it probably takes only about 1 hour. So you can build a very quick pilot with a very small investment, just one gateway. Since the data stays locally inside the gateway and doesn't travel through the internet, there's less security concerns. And our gateways, with just a reconfiguration, can be used for our final value proposition, which is collecting data through the internet. So a full-fledged IIoT application. So this last value proposition consists in, again, collecting data using our gateway from your PLCs and sensors, and then you can push this data through the internet to any IoT software that you wish to use. This can be done using, well-known protocols such as MQTT, HTTPS, OPC UA, etc. So, for example, you could send your data to Amazon Web Services, Siemens MindSphere, Microsoft Azure, ThingWorks, Schneider EcoStruxure, or any other software. And then you will treat with this software the data to do visualization or AI analytics. So sending data through the internet can be done directly using MQTT, for example, or it can be done through our Talk2M service. In this case, this IoT software will use our KPIs. We provide Talk2M APIs. I will finish by introducing our product line. So we provide 2 different families of gateway. So we have the E1 Cozy, which is the simplest of our gateway, which is only for our first solution, the remote access. And then you have the Flexi that can do both remote access and collect data for remote monitoring or IoT application data collection. But we don't provide only these gateways, we provide something very important, which is our Talk2M cloud connectivity service. This remote connectivity or remote access feature is really our strength. Compared to a regular IoT gateway, you have a very powerful way to do the maintenance of your machines from anywhere in the world. Security is very important, and we are audited and certified by several third-party organizations. So we have ISO 27001 certification and ISECOM Star certification, so well-known cybersecurity certifications. Our gateways are very flexible. You can have extension cards for internet connectivity, so you can have internet connectivity through the Ethernet, 4G, 3G, or Wi-Fi. And we also have various means to connect your devices like Ethernet ports, serial ports, IOs, etc. You can read data from many different brands of PLC because we support many protocols. And with our free value propositions, we provide to our customers a very easy way to go step by step all along their digitalization journey. So they can start with very easy things that provide an immediate return on investment. When they're ready to use a little bit of data, they can start with our free live KPI service and our local dashboards. And then 1 year or 2 years later, when they're comfortable with all this and they already have a nice return on investment, they can think about investing in one of these IoT software like Amazon Web Service or Microsoft Azure. I introduced our Talk2M service. Maybe you have never heard about it, but we are the world leaders for this kind of connectivity services. In Europe and in the US, we're very well known. So this service has been on the market for nearly 15 years. We have more than 30 servers all around the world for redundancy. So we have installed a server this year in Singapore and in Brazil, for example. We already have 275,000 gateways connected to our service. So it's quite huge. And these gateways are used nearly all around the world. And our customers have used this service to do millions of secure VPN connections. So all of these millions of connections are travels that our customers could avoid. Instead of traveling on site, they could do their maintenance operations remotely. So I mentioned that we have 2 different security certifications. And in the US, we have been selected several years in a row as the best remote access solution for industrial equipment. And I have a good news to share with you. Just today, I saw that we have been elected again this year as the best remote access solution in the US. So it's 6 years in a row, 6 years that we have been selected as the best remote machine access solution in the US. And one of our very satisfied customers is ABB Robotics. They have been using our solution for many years to connect their robots all around the world. So they have more than 15,000 robots equipped with our E1 solution. And thanks to this, they enjoy huge benefits. So fewer incidents, a faster response time, and more productivity for their robots. If you go on ABB's website, you can see there it's called ABB Ability Connected Services, and they use our Talk2M remote access service and our gateways to collect data for predictive maintenance and other services. So this presentation is nearly over, but our strengths are really security. We always think about security when we develop our products. We are certified for this security. But the reason why we have been very successful is that our products are really, really easy to use. And every time we develop a new feature, we try to make it as easy as possible for our customers. So you don't need to have great IT knowledge to use our solutions. And finally, we are future-proof. We are the leaders on this market with our Talk2M service. We have been on business for many years, and we will be in the business for a long time. And our gateways use open standards which means that in case you don't want to use our talk-to-them service, you could connect our gateways to any OpenVPN server that you could maintain by yourself, or send the data directly through the internet to any IoT platform. And we provide many, many resources on our website. So some demos, if you want to try our solution, resources about security, and a lot of technical support documentation. We even have an e-learning website with about 70 different YouTube videos that show you all the settings of our product. So it's very easy to use, and we provide many resources to help you. Okay, so thank you very much for your attention. This was the introduction of our solution. Back to you, Max.
Thank you, Martin. Great
Thank
info
you.
about your IIoT technologies.
Thank
So,
you.
audience, if you have any questions, just key into the chat room. We will answer it at the end after our last speaker has spoken. Okay. Next, I'd like to invite Shankar from DACOworks, a company that provides cloud solution technologies. They're able to pull out UR robot data and send to cloud, so you can monitor the health status of your robots anywhere around the world. So, Shankar, are you ready?
Hello.
Hi, Shankar. Hi, can you hear me?
Hi, Max. Are you able to hear me?
Yes, great.
Yeah.
Yeah, I can see you as well. Good.
Yeah. Thanks for the introduction. So, hello everyone. So, my name is Shankar. Our company name is DACOworks. We are building IIoT-based product and solutions. So, one of our product is RoboMon. Let me share my screen in the meantime. So, I'm sorry. Yeah. So, yeah, there is some delay in my side. Yeah. So, yeah, let me repeat. So, DACOworks is our company. So, we are offering IIoT-based product and solutions. One of our product is called RoboMon. It's a robot monitoring system, especially for UR cobots. People can use RoboMon to monitor the UR cobot's condition and its performance. So I mentioned condition first here, the reason being many software are there to monitor the performance of the robots, or to monitor the OE metrics of the robots. But condition is very important. Then only you can gauge the performance of the robot. So we focus on both OE metrics as well as the condition of the robots. So if RoboMon is used in a shop floor where UR cobots are being used for automation, people as a shop floor manager or as a production engineer or a maintenance engineer, he can get bunch of benefits out of RoboMon. One is he can monitor the robot's condition and its performance. Along with that, he can also monitor the shop floor level performance, how the shop floor is performing, what are the bottlenecks in the shop floor which affects the performance of our performance outcome of the shop floor. All those details you can watch, and you can take more informed decisions based on the data what RoboMon is offering. So as I told, apart from condition monitoring and OE metrics, there is one more key features is our remote access. Using remote access feature in RoboMon, one can connect to the robot remotely from anywhere. He can access the robot polyscope screen and he can start controlling the robot. If there is any problem with the robot, the user can connect from his browser on his laptop to the robot and start changing the or troubleshooting the problem by modifying the program, or if he wants to download the error logs from the UR cobots, he can download it right away from his browsers, and he can do offline troubleshooting also. So whether the robot is being in a production, or if it needs some attention from the expert like technical team, so they can use this remote access features to get into the robot and to solve the problem quickly, so that they can avoid production loss. And if there is any particular joint is having some problem, then currently what happens is typically if any particular joint has any problem, the user will come to know only if it shows a serious catastrophic error. Until then, the user will not come to know. So after that, all the reactive process is taking place. But if they use RoboMon, they can be more proactive. Before they see any unexpected failure in the robot or in a particular joint, they will take some preventive measure to avoid the failure or to avoid the downtime of the robots. So for that, RoboMon is collecting all the real-time data from all the joints of UR cobots, and we analyze the data and we provide meaningful input to the user. The data, as most of you know about UR cobots, the data can be like temperature, current, voltage, velocity of all the joints. And at the robot level, you can also monitor how the current is, what is the current value, IO current, and the robot voltage data. All those things at every second, RoboMon is collecting from all the robots. So with that introduction, I'd like to touch upon the feature with a small demo. So this is our dashboard. Whenever the user logs into RoboMon, he will be able to see the list of robots which are being monitored by the way, we are also supporting ABB Robotics now. So he can view all the UR cobots current status in one single dashboard. And now maybe there is some problem on a particular robot, or some program needs to be updated. As a UR cobot user, he may not be expert enough in the customer place to change the program. He would give a call to the system integrator or the expert. The expert wants to connect to the robot remotely, so he can connect to the robot and get the polyscope screen on his browser, as you see in this demo. So there you need a 4-digit OTP password to log in, because each time when you connect, there is a new 4-digit password is generated in the robot side. So the remote user should use that password to connect. Otherwise, he won't be able to connect. So now, as you see in this screen, you will get the polyscope screen on your browser, and you can start operating from remote. And if you want to download the log files, you can also click this download icon from this window, and the error log file will be downloaded to your laptop or desktop. Then you can do offline troubleshooting. So now the user wants to know how the robot is performing. Typically, the robots, either single robot or a group of UR cobots, are working in a shop floor together. So the user wants to view how the robot cycles are being performed in the last 1 hour or 8 hours. So as you see in this screen, in this, for example, in the last 8 hours shift, the robot has completed 466 cycles, and its availability was only 27.52%. And wait time is 44%. The wait time is something like, it tells how whenever the robot is running the program, it may be waiting for certain IO signals. So how much time the robot is spending its time for waiting for the signal, that data alone we capture and we bring it to the user's attention. Because these are the serious points. We have to take it really seriously. If these values are going high, definitely it will affect your production. So these are the points we bring it to the user upfront so that he takes some immediate action to that. So, and this data, what you see are aggregated, and the same data you can see in a detailed fashion like this. So for example, in the last 8 hours, it has completed 466 cycles, and how it has completed. For every 1 hour, how many cycles it has completed. And at 8 a.m., there was no cycles. And I mean, here it is a simulator. That's why you see some data is missing, because we don't use real robot for this demo. All of them are simulated robot that we are using. In case, for example, if a particular hour, if the robot's performance is very low, then he can also go back and check the availability chart, what went wrong during that time. For example, the robot is switched off for a few minutes, or it was emergency stopped for some reason. So all those state change details are also captured, and we are showing it to the user to identify the root cause of production loss during a particular time. And this chart will give much more details in a granular level, how much time exactly the robot is running the program. Maybe the robot is powered on, it's switched on, but how much time in a shift it was running the program. This will give more granular input to the user. Out of 8 hours shift, how many hours the robot was really utilized for the production. And this wait time data, what I mentioned, that wait time data is distributed in a pie chart like this, where you can identify for which IO signal the robot has spent more time to receive that data. So this also will help the user to optimize the program so that the production time of the robot, or uptime of the robot, or runtime of the robot will increase. And if there are any alarms found in the robot, currently we download the log files and manually we will check. Now that manual process is not needed. Our RoboMon itself is collecting all these error log information from the robot at every second. Whenever new error logs are found in the controller, robot controller, we will immediately export that data and bring it to the user in the alarms window. Now, performance related data we have seen. Now the user wants to know how the condition is going for the UR cobot for each joint. So we are almost like collecting 20 plus parameters from all the joints, and we show it to the user both real time and historical. So for example, if you look at here, I have plotted a graph where user can view the temperature and current information for shoulder, base, and he can also find out robot current and IO current data. And this data is coming at every 1 second interval. And the same data is captured and stored into the database. And we allow the user to set a threshold for these values so that whenever we find the data is breaching the threshold value, we will immediately notify the user via email or SMS, so that the user will take immediate action to that and to avoid unexpected failure. Apart from that, we also support, because through AI and the ML methodology, we also provide predictive maintenance on top of this preventive maintenance feature. That will be more of customized solutions on RoboMon with respect to a particular application where the robot is performing. So now for a shop floor manager or a production engineer or a maintenance engineer, monitoring the robot data is important, but at the same time, monitoring holistically at a shop floor what's happening, that is also important. So we have a feature called shop floor where the user can create a shop floor and he can configure a shifts, and in each shift he can assign list of robots which are doing its job in the shop floor, and he can configure the shift details, and he can also say to which user that summary of the shop floor or shift information to be forwarded to. So whenever the shift is completed, the assigned users will get an email notification with the details about what happened during shift, how many are done, what are the targets, how much is achieved. All those details will be sent as a summary to the user. So I will just show one data here. So this is the shop floor summary where the user can, this is more of a real-time data. So at live, what happens on a particular shop floor in a particular shift, how many are completed so far from the shift start time, and what is the OE metrics of all these robots which are performing its job in a shift on a particular shop floor. And the same data, the user can view much more granular level where you will get more finite values like at each robot, how much its runtime, how much time it was in idle state in that shift, how much time it was in downtime, and all the wait time data he can see, how many times it was in down state during a shift time, plus the list of alarms which are found during shift time from the robot, from all the robots. All of them will be brought to the user's attentions in the alarms window. Again, one more step further. Now, it's not just only the robot doing the job. Along with robot, there are other assets are also functioning, which to provide the end results to the user. So, and for the user, those assets, performance, and its data, real-time data also are very key to make some decision. So we also have a feature called IIOT tags where you can configure IO servers. In this case, it can be a PLC or it can be any digital equipment from where the user wants to collect the real-time data. So you can configure the IO servers and you can collect the IO tag data from those IO servers, and you will be able to set some notifications for those IO tags. For example, if let's say you are collecting some pressure or humidity information, for example, from a PLC, and if you want to set some threshold values for those IO tags, you can, while configuring, you can set threshold values, and if there is any breach, Robomon will notify the user via email or SMS. So, as Max told, Robomon is offered as a cloud solution and as an on-premise solution. So, if you prefer to keep Robomon software to be deployed within your office premise, if the customer wants to keep it within his local area network, you can deploy as a Windows-based software in a PC. And if you ensure that the LAN connection between a robot and the PC, Robomon PC, is connected, then Robomon will start functioning and start collecting the data. You don't have to install or you don't have to connect any extra hardware with the robot. There is a small URCAP software which is certified by Universal Robot. If you install that URCAP software in the robot, it will start collecting the data and push it to the Robomon server. So in case if you want to have a cloud-based solution. The same, we have a cloud-based solution. At the same time, we also can offer a dedicated cloud server for you, where you, if you wish, you want to keep your production data in a dedicated server, we can deploy the RoboMon software in a dedicated server, which is assigned for you, and you can access the data and the robot from anywhere in the world. So these are the features of RoboMon, and our team is keep working on the features, and we are also building AI-based, ML-based predictive maintenance features, using which you will be able to detect the anomalies in a particular robot or in a particular robot joint before that robot or the robot joint goes for a failure. RoboMon will be able to predict and inform the user well in advance. So with that, I'm done with my demo. So if you have any questions, I can answer to that.
Okay, thank you, Shankar.
Yeah.
Okay, finally, it's time for Q&A. So if anyone has questions, please type them in the chat room. I'm sure the speaker will be pleased to answer them. Okay, let's see if there is any questions. Okay, any questions from the audience? Okay, let's wait about maybe 1 or 2 minutes. Okay. Okay, I think there is no.
There is a question. There is a question asked. How about software maintenance and upgrade? Is this for RoboMon?
Sorry.
There is a question in the chat window. How about software maintenance and upgrade? I just wanted to know, is it for? Yeah. Okay.
That to you.
Yes, this is for RoboMon.
Okay, maybe Shankar, you want to answer? On my side, I can't see any questions.
Okay.
Yeah.
Okay. So, so there are two things. One is with respect to software maintenance. Along with the license, first year maintenance is always at free of cost. If the user wants to have maintenance for the second year onwards, we also provide maintenance to the customer, and any software updates, any new feature that is added in RoboMon, that will be treated as a software upgrade, and we'll help the customer to upgrade the software with the new features.
Okay. Thank you, Shankar. So, is there any more questions? Okay. If not, I'd like to thank everyone. Okay, ladies and gentlemen, we have come to an end of our webinar. Thank you very much for your participants. I'd like to thank all speakers for the presentations, and I hope you enjoy the program. If anyone has any questions or inquiries, okay, just email to us and we will approach to you individually. Thank you and see you on our next webinar.